evening to our European colleagues. Welcome to one and all. I'm Dr. George Thompson, President and CEO of Chemical Compliance Systems. Over the past 30 plus years, CCS has compiled the largest relational hazardous material databases in the world, and we've developed 38 web-based software systems. 8 of the systems have been integrated into what we call Green Suite, as you can see here on the first chart up. The focus of our business has been to assist academia, government agencies, and industry in using our chemical hazard databases and software algorithms to perform risk assessments. We've been doing that throughout our 30 years of existence. The 2016 TSCA amendments now make risk assessments a requirement, at least within EPA in the US. This webinar today will intentionally review the legal requirements that define much of the EPA risk assessment process, but also demonstrate how our Green Suite capabilities can assist in conformance to these requirements for potential clients. However, we recognize that the pre-publication copies from the EPA of their proposed regulatory rules for implementing these requirements have just become available this week, and that may alter some of the details that we're providing here, because what we've prepared for is based upon the law itself. In addition, the inauguration of a new president in the United States tomorrow may also alter some of these details depending upon how his administration chooses to implement this, the regulations that come out of this standard. We will be monitoring the process over the next few months as EPA proposes new rules and definitions for the implementation, and the administration, of course, changes hands. So the proposed regulations, the pre-publication ones that are out now, of course, were developed under the Obama administration concepts and philosophy, and that may be very well changed under the Trump administration. I'd like everyone to be aware that all the charts you see today will be provided to each participant this afternoon or tomorrow morning at the latest. We're also videotaping the presentation, and this will be posted on our website, which will be indicated on the last chart in the presentation. I will not intentionally cover every point in every chart. I want to try and leave some time at the end for questions if I can, and that we have a lot of material to cover, so that if you will hold your questions till the end, I'm going to try and reserve 10 minutes if I can, and with the number on board there may be that may be too small a time. I will be available beyond noon when this is scheduled to end for anyone that wants to stay on and ask questions or discuss it. So with that background, I'd like to start with the first chart, if we could, that is not related to the law. I want to summarize first of all some of the historic toxicology definitions that have led to some confusion in the arena of risk assessment. And so I listed them here to kind of make sure that some of you who are on the line are every bit as knowledgeable, and perhaps more knowledgeable than I am in these matters, but some of you aren't. And so I want to make sure that some of the basic terminology is understood. So the first 3 grouping there of hazard, toxic, and poison, those terms are used both in the technical and the lay literature, and have a certain connotation that is negative, typically in its nature. They are sometimes used as synonyms, but hazard in the context of what is being discussed in the law and the pending regulations is a measured endpoint. It's an intrinsic factor related to a chemical impact, but it's tested under very specific conditions. And so when we talk about toxicity or poisonous effects, those can be certainly hazardous impacts, but they're usually used in a more emotional kind of state than where hazard is a specific estimated or measured adverse effect. Risk, on the other hand, differs from hazard in the sense that it's a calculation or a derivation derived from an integration of information about that includes hazard, but it also accounts for exposure factors and conditions of use as indicated in the bullets there. So the amount, frequency, and duration of exposure, the route of exposure. So oftentimes, for example, in cancer research, many of the cancer studies with chemicals are done by the oral route, sometimes by the inhalation, not very often at all by the dermal route. And so whether a chemical is a carcinogen or not, in its definition in the literature, is often not specified often by the specific conditions of that test that gave it that label. A hazard assessment, which has become an increasing norm in the United States at least over the past 5 to 7 or 8 years, is simply using the hazard data, the measured deleterious effects on the environment, on health or safety. Safety might be something like flammable or explosive, and classifying a chemical based upon that hazard. A risk assessment, on the other hand, takes into account hazard, as indicated there in the first bullet, but it critically incorporates also exposure elements and conditions, and those conditions include the intended use conditions. And then the object of a risk assessment is to see if a process can be implemented to manage the risk at an acceptable level. And you're going to hear some terminology as we get into the law that's actually written into the law for the first time that will influence this. But as indicated in the equation at the bottom, risk then is a function of the hazard and the exposure, with exposure also including not just the routes but the amounts, the use conditions, etc. And the law has recognized that and will incorporate many of those. On the next chart, we have some new definitions that are written into the law. It specifies over and over that EPA has to consider the conditions of use. Those can be known or reasonably foreseen, but they also encompass where is the exposure occurring. Is it in the manufacturing, processing stage, or distribution and commerce, or its use or disposal? So that condition of use, EPA has to determine and base their risk assessment on each stage in that condition of use. The law specifically focuses upon potentially exposed or susceptible subpopulations, and some of those can be infants or children or pregnant women, workers, or the elderly. I particularly like that last phrase of giving me special consideration among the elderly. But they are incorporated because of their potential greater susceptibility. The term unreasonable risk, I think this is the first time I've ever seen it in a law or regulation, and it's repeated over and over in the legal statute. Obviously, this implies that if there is an unreasonable risk, there is also an acceptable risk. And EPA is charged in each chemical that they review to determine if it has an unreasonable risk in its life cycle use or applications. The definition of where unreasonable risk will be defined is going to be in the pending proposed regulations. I said they just came out in the last couple of days as a pre-publication draft. I haven't studied them completely yet. I have reviewed the summary, but that definition of unreasonable risk will be part of what's out there for public comment, and will be scrutinized by parties on both sides of these issues. EPA has already started a process of reconsidering what a small business is. They have had a previous definition. They have, under this statute, reconsidered what it will be, and currently it is defined as a business that has less than 40 million in annual sales and no site among a corporation with more than 100,000 pounds per year of production or use of a particular chemical. A second definition in the current law is that it's less than 4 million in annual sales, and there's no quantity restriction for companies that are in that purview. They put out a Federal Register notice back in the middle of December. The deadlines for comments was 2 days ago, so it's too late to comment on it, but they were soliciting to see if there should be additional considerations into that definition of small business, and I'm sure that will get into a proposed rule and eventually a final rule as we move through the next few months. The next chart is an overview of the amendments. We're going to go into different sections of this in detail in subsequent charts, but as an overview, this is risk-based. It's no longer enough for EPA to classify chemicals based upon their hazard only, and it applies to chemicals and mixtures. One of the new requirements is that old chemicals, those that exist in the commercial pipeline, are no longer exempt. Under the original TSCA, they were grandfathered. So if they were already in use, EPA didn't need to look at them. Under this law, that is a specific requirement that they also look at chemicals that are in the existing marketplace and see if, frankly, they have an unreasonable risk. Then they need to be restricted in one way or perhaps even banned. Again, you'll see here the susceptible populations is part of that. The risk priorities, there's a sequence, and you'll see this as we go through some of these charts, but the basic prioritization process, which is step one in the risk evaluation, they have to classify a chemical as to whether it's a high potential risk or a low potential risk. The criteria for those definitions are yet to be enumerated and agreed upon in a final rule. That's part of what's in this proposed rule that's just been in pre-publication format now. Once a chemical is designated as a potential high priority, then that triggers a series of risk assessment deadlines, and we'll go through some of those deadlines in subsequent charts. But there are chemicals then in the first look where EPA can say, no, based upon the information we have, they are a low priority, and they don't do risk assessments on those chemicals, but it is based upon the information available. One of the requirements in the law is that they had to identify the top 10 or the first 10 chemicals for risk assessments. They did that. They published that list on November 29th of 2016. I've listed those 10 chemicals here. They have already put out proposed rules on methylene chloride and trichloroethylene in the last week or so that would restrict or ban those, and I'll talk about those again a little bit later. So they're already moving forward under the current administration and the current expectations with some of these materials on this first 10. One of the steps after they do the prioritization, then they have to publish a document that says, here's the scope of information we're looking at. And they have to complete that scoping definition within 6 months of its original designation as a potential high priority. And that scope will include what hazards they know about the chemical, the susceptible subpopulations that they're aware of, the conditions of use, and the exposures in those conditions of use. And by EPA publishing that as a proposed notification, this scope, that invites the public then, in any element in the public, to comment on the scope and add data about any of those elements that are going to be included in the scope definition. There is a 3-year risk assessment completion deadline, so once they have designated a material as a potential high priority, they only have 3 years to complete the risk evaluation process. If it's an unreasonable risk, at the end of the risk evaluation, then they have 2 more years to mitigate the process of whatever they conclude in that final rule, whether it's a ban or a restriction or whatever. And then by the end of December of 2019, they have to have 20 chemicals continuously in the pipeline. So they're starting with 10 this year, but within 2 years they have to be doing 20 a year minimally. But think about that. Right now EPA's inventory is somewhere around 84,000 chemicals, and since they're looking at existing and new chemicals, it's going to take them a long time to work through that whole process, and that's why the prioritization step becomes so critical. This chart on the prioritization shows that the risk-based screening process, which has not been defined, the pre-publication document's only 2 or 3 days old, but it has to be final as a rule by the 22nd of June this year, 2017. That's already in place, and it's going to probably within the next week or two, it will be available in the Federal Register as a proposed rule for public comment. As I said before, it will take into account the hazards. It'll take into account the manufactured or processed data that they have, the volume there in their data sets, and the conditions of use. You'll notice under exposure potential in the center of the chart there at the top that there is a priority in the law itself that they consider persistence and bioaccumulation as key factors in their evaluation. And the EPA has long had a system of evaluating persistent bioaccumulative toxins, or PBTs, and the maximum or worst score they can get is a 3. And if they are a 3, then they would be priority items here for the screening process. But one of them could either be a moderate, which is a 2, and still fall into that higher category. They also include what the law calls known human carcinogens, but most of the carcinogen lists they have known as a top priority. It will remain to be seen when EPA's regulation comes out if that includes possible human carcinogens or probable human carcinogens, which are some of the descriptors in the available resources. The high acute and chronic toxicity, I emphasize in the middle of that there is an and. So we're waiting to see what they're saying if it has high acute toxicity but not high chronic toxicity, or vice versa. Will that be considered the criteria for establishing a material as a high priority? The storage next to close to water sources is key in this thinking. Obviously this is EPA, so those factors will all go into this risk-based screening process. There are 2 categories, classifications I've already mentioned. One is high priority and one is low priority. The low priority, they just have to be able to document that they have sufficient data and what that data is, and that it doesn't meet the high priority criteria, which are over on the left in the bullets. And the bottom line is that EPA has concluded that it's an unreasonable risk to health or the environment. That's an or, not an and that it has potential hazards and potential exposure routes that are of concern either to health, human health, or the environment. So there is a criteria here for a high priority substance. The bottom one is that there's insufficient information to designate it as a low priority. That would make it an automatic classification of high priority, because under this law EPA can request manufacturers, processors, and importers to provide the data that's necessary. When these public documents go out, particularly the risk-based screening process, there's a 90-day response period for the public, it can be extended by another 90 days, but there is a deadline in the law that it has to be completed by June 22nd. There is an additional testing requirement, as I've quoted here from the law itself, that they can require the development of new information if it's necessary, but in order for it to be necessary, they have to document the rationale as to why it's necessary and what its purposes are. So in that context, they're looking to establish these priorities, and remember on the previous chart, if there's insufficient data, they cannot call it a low priority material. So this gives the EPA the authority, if you will, to require testing or acquisition of data. That's a new orientation here in the United States. Manufacturers have never been required to provide that kind of additional data, and that was considered one of the major flaws in the old TSCA law that has been remedied here. There is a tiered screening process that's required in the law, and they must, when they request the additional data, they must also prescribe the methodologies that would be used to generate that data, so that it isn't so that whoever's providing the data isn't missing the mark requested by EPA. The next chart on conducting the risk evaluations, how those are going to be done, that's going to be stipulated in this proposed rule that's about to be issued in the Federal Register. but they have to consider hazards and exposures under the conditions of use, but those are exposures to human health and or the environment. The exposures, one of the deadlocks in Congress for a year or more was how they were going to define exposures. And in the law, they have now combined the two opposing viewpoints so that EPA has a choice. They can either do an aggregate exposure for every use and everything summed together, and that's the exposure level, or they can do a sentinel exposure, which is the worst exposure they found, and if that one's controlled sufficiently, then it will reduce the total risk. Those two philosophies were not amenable in Congress in the debates, and so in the final law they put them both in. And then when EPA publishes their proposed rule, and they will need to justify whether they used aggregate or sentinel exposure, and the public can then comment on that. The risk evaluation will include likely exposure factors under the conditions of use, and we've listed those again, and you'll see those several times: duration, frequency, concentration or intensity, the number of exposures over a period of time, etc. And they will have to define how the weight of evidence for hazards and exposures, in both cases hazards and exposure weight of evidence, are viewed in their proposed rules. If they conclude after a risk evaluation that a chemical is an unreasonable risk, then the law has 7 different options that EPA can implement. So it doesn't mean that it's prohibited or banned. It can, but they can restrict the amount. They can restrict it to or ban it from a particular use or below a specific concentration. The trichloroethylene proposed rule that it just issued from EPA is banning it from use in degreaser, vapor degreasers. That's their proposal. They are working on methylene chloride. It has been considered that they ban that from paint strippers, but they're awaiting information on the commercial furniture industry before issuing that proposed rule. So we're going to have 2 templates here from this outgoing administration to see how what is their thinking, and obviously, as I've already alluded, that can be changed by the incoming administration. They can have an option here, number 4, where they're only requiring that manufacturers or processors make and retain records. They can regulate how the manner or method of the commercial use, so they could restrict it from some materials and not others. Similarly, they regulate the manner or method of its disposal. And they also, at the end, could have make a determination that the manufacturer processor had to give notice in their supply chain to their distributors, the public, and either offer replacements or repurchase, particularly if it's banned from that supply chain. And then overall, as indicated in the bottom note there, any of these 7 options can be specified for a specific geographical area, and it remains to be seen how EPA might plan to interpret that, where it's restricted in some way in some area of the country but not in others. The next chart on the rules content, there's a lot of detail to this, but they have to acknowledge in a transparent way what information's available. They have to identify the hazard effects on health and what is the magnitude of exposure. So they're looking at, in that case, at hazard and exposure for health impacts. The same thing on environmental in the 3rd bullet. But they also have to look at the benefits of that chemical substance for various uses. That's why usage condition is important, because at the end they have to look at the benefit versus risk ratio consideration. They eventually, in the final rule, have to consider economic consequences, but not in the initial risk evaluation. They have to identify restriction alternatives and which ones have they looked at and why. If it's in an article, so let's say a piece of furniture or some material like that, They can have prohibitions and restrictions there also. But it's related to the amount that's in that article. And so this is where, again, the exposure becomes very critical, because that's often diluted in articles. And then there are exemptions. There are a series of exemptions for specific conditions of use listed here. I've got down 6 different bullets that we've extracted from the law, and those all have to be written up in both the proposed rules and the final rules for a specific chemical. Now, looking at the timelines for implementation of this by EPA, 180 days after the enactment of the law, which was June 22nd, 2016, they had to publish a list of 10 chemical substances, which they did on November 29th. That was their first deadline, and they met that. 3 to 6 months after they have identified a chemical, in this case those 10 chemicals, they have to publish their evaluation scope that they're planning to use, so that the public can comment on it. And we've talked about that before and some of the elements in that. A year after the enactment, they have to establish the rule for the risk-based screening process. This is a critical document, because the intent here is to require EPA to be totally transparent in what they're considering, and giving the public time to comment on that, to strengthen it and make sure that it is scientifically valid. And that is the one where the pre-publication is already available. It has not appeared in the Federal Register, and it's going to be very interesting to see how the new administration deals with that. After they've initiated the risk evaluation, so think of these 10 chemicals, they have 3 years or less to complete the risk evaluation, and then once that's completed, they have to publish the results of that and give the public 30 days notice for comments of the draft risk evaluation. I can find nothing in the law that identifies what is a time frame for the final risk evaluation, but the next bullet there does indicate that less than a year after the final risk evaluation is published, they have to publish a proposed rule, and then after the proposed rule, they have to publish a final rule. So there will be lots of time here for EPA's decisions to be scrutinized by all parties, both sides of the issue. And there are certain extensions available, but those are details depending upon the circumstances for a specific chemical. The next to last set of bullets there, these first 10 chemicals, the proposed rules have to be completed within 3 years, and then of course they have 18 months to promulgate the final rule on those. So as you can see here, there's quite a bit of time from November 29th, when they listed these chemicals, until that final rule for each of those 10 chemicals is promulgated. And it'll be interesting to see how this is handled with budget changes under the new administration, etc. But in 3.5 years from the date of enactment, they have to be doing 20 chemicals a year designated as high priority, but they also have to have designated 20 chemicals as low priority by that time frame. So that's an overview of the legal requirements. As I said, we will likely have subsequent webinars where we've read and analyzed the regulations that EPA puts out on those. Now I'm going to transition and indicate how our Green Suite capabilities can be used to assist organizations at every level, from EPA down to the manufacturers and importers, distributors, in conforming to these requirements. I'm going to go through these somewhat superficially. We're going to have a more detailed Green Suite webinar in a couple of weeks that we have an announcement at the end of this chart. So I'm not going to go through these complete in detail, but let me simply say that we have a chemical and product database at about 80 million data elements. As you can see, it includes the chemical regulatory product and supplier data tables. In the next chart, I list some of the details, some of the statistics. We've been compiling this data since '85. We have about 280,000 chemicals total in the database, but we have detailed data for 44 ecological health and safety endpoints on over 27,000. I put 3 or 4 samples there: fracking chemicals over 1,200, munition chemicals. We have about 1,100 cosmetic and SPF chemicals. We also have other groups of chemicals, and we can compile these inventories, if you will, and the associated data for chemicals in any industry. The data is compiled from over 1,000 public data sources, and among those we have over 800 chemical regulations, mostly in the United States, but we also have considerable international among those 800 regulations. The next chart is the critical chart. This is how we score a chemical, and we use it for both hazard and risk assessments. As we see in the subtitle, it applies to chemicals, products, processes, and waste streams. Basically, the 27,000 chemicals, we've compiled the data from these 1,000 publicly available sources on the 44 endpoints over here on the right. Those endpoints were derived from the consensus standard that was put together by about 185 committee members across many stakeholder groups, and we have compiled the data for each of those individual endpoints. We summarize the data then, moving from the right on this chart. So for example, at the very top where we have air, we look at its persistence in air, its partitioning or the amount in air, the toxicity in air, and the long-term effects in air. Then in the next subcategory group, we look at air, water, and soil totals. Those are merged together to give us an ecological score, and that's merged with the health below it and the safety to give us an overall a green evaluation score. All of these numbers in this chart will be based on a scale of 0 to 100. So the green grade over on the left, and all of the numbers on the 44 endpoints are somewhere between a score 0 and 100. And the normalization to get them on that level, we have gone through a normalization process because each of those 44 endpoints is in its own unit of measure. So LD50s are in milligrams per kilogram, persistence is in time. And as a toxicologist, the question is, how do you compare one to another? And the answer is you can't really when you're trying to determine which is the worst. And so we normalized each endpoint on this scale of 0 to 100. So the worst value in a forced ranking of the data for persistence in air gets down here at where we have a P at the bottom, a 0. And the best value, or the least persistent value, gets an A at the top or is assigned 100. All of the values in between are assigned their corresponding position on the normalization ranking scale between 0 and 100. We did that for each of the individual 44 endpoints back in the early 2000s. So in 2002 and 3, we were going through and setting those parameters. Now when we get new chemicals into the database, we look up those 44 endpoints and apply them against those same rankings to determine what their normalized score is. So we have the actual values in our database, but we also have the normalized values. We mentioned before that our overall assessment has 44 endpoints, but because not every chemical has the overall concern, we also have identified the dermal concerns, and that's written into this TSCA amendment standard. And so we have eliminated many of the endpoints. There are only 6 endpoints that are affected when it's a dermal concern, but the algorithm is the same. It processes the data from the right to the left and gives us a dermal green grade. There is a dermal and oral group so that you can have it on your skin and in such a way that you might consume it or ingest it. And in that particular case, there are 13 of these endpoints that merge to give us the overall scores moving from right to left. And then finally, for inhalation and dermal together, there are 27 of the 44 endpoints that are used to merge from right to left. So we can do an overall chemical or product or waste stream manufacturing process assessment for any specific route of exposure or for all of the exposures combined. Green Suite, or the Enhanced Green Suite as we call it, is made up of 8 optional hazard and risk assessment tools or modules. The 4 big green boxes in the middle all use the 44 endpoint criteria. The 2 blue boxes for risk characterization ratio, or chemical and product RCRs, are an expanded exposure scenario developed from algorithms that the Dutch Food Directorate developed, and their corresponding database in their system. And then we have a process engineering tool that has 44 criteria with the information coming from industry. You'll notice on the left that the top row of 4 modules are typically used by product stewards and professional people like toxicologists, ecologists, etc. The second group are used by the process engineers in evaluating the process itself, and the bottom group is often used by procurement people as they're trying to determine the relative rankings, if you will, of the risk from different products that they're procuring. The algorithms on the next chart, we have the algorithms for the hazard side on the left for chemicals, and the risk side on the right are the same, except that we incorporate, as you can see in green on the right box, the constituent chemical concentration in a mixture, and that is used then as a dilution factor to do a first order risk assessment in our 4 central Green Suite modules. We have a different approach for the RCR 2 blue modules that we had on the previous chart, but the context here is that the algorithms are straightforward and easily documented as to how the numbers are calculated from the normalized value to the overall score where they're all combined. In our system, in the next chart, the scores, as I said, range from 0 to 100, but because many people don't know how to interpret a score when they see a ranking on a chemical or a product and it says it's a 72, in the early years, 10, 12 years ago, we were asked, what does that mean? And so we developed a series of options. So there's an alpha ranking. People are more familiar with grades on a school report card, and so we have an A through F ranking there that corresponds or derived from our numeric scores. We also have text descriptors, which many clients prefer because it is a type of description as opposed to just a number. And we have a color code scheme that some people prefer, and it is more generic and not as specific, but again, the intent here is to be transparent to identify how those are used. There is a current voluntary standard being developed by the Green Building Initiative, or GBI. The ANSI standard is out for its second public comments. The risk assessment section in that standard for building products includes the exposure scenarios that are very, very parallel to what's in the TSCA amendments. Green Suite happens to be specifically mentioned in this standard as conforming because it looks at human health, safety, and ecological effects. That standard is scheduled for completion and application in the building industries perhaps later in 2017. This certification is a simple report that's one option output so that we can certify the overall rating of a product. In this case, it's listed as long-lasting, never to be replaced spray-on, and it came out as highly probable non-risk. The question then is, what does that mean? And the next chart shows the numeric in the bar graphs there that it was not highly probable non-risk because everything was 90 or above, and we show it for the green grade environmental, health and safety portions, along with the scoring. The next chart shows the engineering or process tool that we had with the 24 endpoint criteria. That data does not exist in our file. The previous modules, all of the data existed in our databases. This is process specific, and the information has to be provided to us by the manufacturer, but it is normalized in a similar way to the other chemical data so that we can compare the process score here for very different kinds of endpoints. This is waste and water use and energy consumption, etc., and not chemically oriented at all, but we want to compare so we can see is the manufacturing process or the chemical of greater concern. The modules that we have, those 8 modules, are designed so that they fit each stage of the life cycle. So down at the bottom, the red number or the red indications there are the modules that CCS has and which stage of the life cycle they're used in. Last March we actually gave a webinar that showed how particle board analyses from Green Suite at each stage of the life cycle could be integrated quantitatively into existing life cycle assessment software and improve the specificity and quantitation in that LCA. We gave that presentation also to the Europeans about a month later, and then last fall we gave it at a national scientific conference of the ACLCA down in South Carolina. So the risk assessments can easily be incorporated into life cycle assessments to add the quantitation. The historic applications of Green Suite I've just put up here. I think it's 20 different industries. The basic point is that Green Suite can be used with any kind of chemical in any industry. You'll notice that some of these are articles, like furniture's on there, munitions are on there, and a number of them are chemical compositions such as paints or adhesives or cosmetics. So the industry type doesn't matter. In munitions we've done bombs and grenades, etc. So those are articles, but we're looking at the chemical constituents in those and what are the risks and hazards associated with them. And finally, Green Suite is designed so that it can apply across the entire supply chain, so that we can carry the risk assessments from the 3rd level supplier to the 2nd level supplier, 1st level, and finally to the manufacturer. The advantage to this is in the bottom footnote that this enables us to clean the supply chain from the bottom up. Retailers have been compromised in trying to clean the supply chain from the top down, because the manufacturers are reluctant to divulge openly the compositions of their formulations and products. And by us having a non-disclosure agreement at each level, then we can incorporate the analyses, because the analyses, the analytical summaries that you saw at the beginning show the scores across that report card, but they don't have to divulge to the up the supply chain the individual constituents. So there is a provision where we can protect confidential business information. I'm going to pause at this moment with the chart presentations, and we're going to demonstrate the chemical and product modules briefly, so that you can see the beginning. But we're going to have, as I said before, another webinar in a couple of weeks that I'll show you in a minute, where we're going to go into this in detail. But for the demonstration purposes today, I just want you to get a sense for how this can be done. So we're going to go to the chemical module first, and we're going to input, I think it's 3 CAS numbers, specific chemicals, that that we're going to compare. And so as we put those CAS numbers in into the system then will go into the databases and pull out the data for those 44 endpoints, and this demonstration is going to be a accumulated hazard analysis as a.
Could you put the phones on mute so we don't hear that irritating breathing, please?
Yeah, somebody's breathing on the phone. Thank you. So as he's just putting in these CS numbers, the reason we're doing it this way is that we want to show you how the system can actually compare chemicals. And and so he's put in these 3 CAS numbers down here at the bottom. All of these, I think, are on the top 10 that EPA has selected. And so now he's just going to process those, and here is a table, if you will, that ranks their concerns. And the way this works is that you see the green grade there runs from an 88 for the most green down to a 70 for the least green. So of the 3, there's quite a spectrum, 18 points difference. And then going across, you can see the ecological, the health, and the safety scores. We won't today, but you can go inside of each of those ecological health and safety scores and see the details of each of those endpoints that apply to health or to ecological or safety. You can go into the regulatory application over here and see what laws are specifically impacted. We're developing a new table that will be in the next webinar on Green Suite. We couldn't finish it for today, where we will actually show you the persistent bioaccumulative toxins, carcinogens, the criteria that are written into the law, so you can get that as a report on regulatory, or you can get it very different regulations if you want to apply it in Europe or somewhere else. But the context here is that you saw that it took about 3 seconds to calculate these scores for each of these 3 chemicals, and by ranking them you can see which ones are better or worse. We often do this kind of an analysis when somebody wants to do an alternative assessment, so they're looking at 2 or 3 materials or maybe more that they want to consider in a process or a product, and we can rank them and get into the details of what's involved. We're also going to show a similar thing on the product tool. The product tool has 2 modes of operation. One mode is in the evaluate mode, where you want to evaluate your existing product. That's what we're going to demonstrate today. It also has a design mode, so that as you're designing a new product, you can do a green assessment. And the evaluate mode, in this demonstration, we're going to use a national stock number. In the Federal Supply Catalog, national stock numbers list products that are considered functionally equivalent. So in this case, we used a national stock number that pulled up these 7 spray adhesives, and we're going to process those, and then we're going to show you the relative ranking of these functionally equivalent products. But the question is, are they also equivalent from a hazard, or from a risk basis? The chemical analysis that we did before was a hazard basis because we didn't use exposure levels. We can do that if the manufacturer tells us the exposure levels, but when we don't know it, it's hazard analysis. In this case, because we know the formulations in each case, this is a risk assessment, and you can see that the most green has an overall score up here of 90, and the least green here has a 75. So there's a 15-point spread between these 7 materials that are viewed as functionally equivalent. And when we've looked at different NSNs where the government has defined the equivalent functionality, we commonly find that there's quite a spread in their overall assessments. One of the things that I didn't say, and it doesn't show in this chart, but if there is a score that's less than 65, it will show up on these in any of these analyses in red, so that it's easy to see, and that's what we would consider an extreme or a high priority consideration. And so the context here is for that Green Suite has all of this data behind it. It's been seasoned across many different industries, and we can use it to help organizations of any kind conform to the TSCA amendments. The last thing I want to go through is the risk characterization ratio modules. Those were the 2 blue ones. And as an overview, the difference is now that this is not using our in-house databases. This is data that we've drawn in from the Dutch Food Directorate. But the context is that they have very specific product article categories here, Each of those contains a number of subcategories. So for example, cleaning products, they have 6 subcategories and 31 detailed categories, and those all contain different exposure considerations. We can do inhalation, dermal, or oral routes of exposure in this, but there is no process application in this. This is only final product consideration for exposures. It is designed originally for consumer exposure, but with modifications we can enhance it so it can be used for worker exposure. The entry here is that the manufacturer inputs their product identity and composition on the top of this. This is a web-based entry system if they prefer, or we can enter it here if they send it to us in a confidential package under an NDA. And then we identify here the intended application. So for demonstration purposes, we pick the do-it-yourself category. Sealant, within the sealants, we're going to look at an assembly sealant in the demonstration today. For the assembly sealant, there are different exposure factors that the system identifies. These are built into it, but they can be overridden on the right side. And as we've used this in the US, a number of industries tell us that these values might apply in Europe, but in the US they need to be modified. Well, the system is designed so that you simply put in the override values on the right, and you can create a different kind of analysis. So it has the frequency of exposure here up here of once a year, and that could be an consumer exposure, but you might put 50 in there if it's a worker exposure, and put that in the override column, and it would use that. So you can see here under the general dose considerations, the exposure considerations, you can see the inhalation and the dermal in this case from that particular sealant category. And then at the bottom here, the mode of release of the constituents in that, you can determine if it's instantaneous, constant, or evaporates over time. We've checked here the constant rate, and that's what will be used then by the algorithm to calculate the exposure dose. In this case, this is simply a summary of the exposure scenario and what we've incorporated. The frequency, for example, we changed to 3 times a year. Some of the other values we may have modified, but this is what the system's going to use now. And so when we go beyond that into the system for the actual analysis, this is the calculation. Now, in very small print down here at the bottom, the footnote says that we selected xylene because of the green suite analysis using the 44 endpoints. It was the chemical of greatest concern from an inhalation exposure in this particular sealant product. And so when we put that xylene then into this into this system module with the exposure considerations we just showed you, it automatically then calculates for you the different exposure doses, and it can be an acute exposure or a chronic exposure, and the doses involved with each. Similarly, on the dermal side, the green suite selected the esterophenol as the chemical of biggest dermal concern, and so we put that into the system, and it calculated the dermal doses of exposure, as you can see here. To do a risk characterization ratio, you take that acute concentration or dose or the chronic concentration dose and divide it by a no adverse effect level, or a DNEL, and that creates the ratio. So you can have an acute ratio, you can have a chronic ratio, and you're looking to see whether that ratio is greater than or less than 1. And in the next chart, I think we showed the values. These are the values here for both xylene and the esterophenol, and you can see the RCR in the middle there. Both of those are significantly less than 1 based upon the reference values that we selected for the no effect levels. And the risk characterization ratio then indicates that there is reasonable uncertainty of no harm from this. So in these modules, they calculate risk as yes or no. In our green suite modules with the 44 endpoints, it's on a scale of 0 to 100 that we can describe or quantitate. So we have 2 different ways of looking at risk. The We also have software systems that are used specifically for munitions applications. There are a few of you on today's webinar that also are aware that we're giving this similar webinar, but it'll exemplify the Max Suite next week. But it's the same basic database that feeds both of these. The next chart is that just to draw a few conclusions here. Chemical and mixture risk assessments are required by law in the U.S. That's new. Hazard-only assessments are no longer accepted within EPA. The Green Suite risk assessment database and software algorithms have been used now for more than a dozen years, 13 years of experience there across many different industries. They can be applied to any industry and each life cycle phase. Green Suite facilitate the alternative considerations. So if you want to improve your green scores, we can suggest alternative constituents be added. And many of our customers now are using our risk assessments to strengthen their marketing strategies. And by that I mean they're actually using our reports as an independent third party to provide to their customers. The last chart I have is about the next webinar. No, go back. Because we didn't have time to do a detailed demonstration of Green Suite, we have scheduled a webinar on Thursday the 26th of January or Wednesday the 1st of February if you can't make the first date. We'll have that for an hour and we'll go through the details of how Green Suite works, how we weight the endpoints, how we fill data gaps, a number of details that we didn't have time for today. The pre-registration is the same as you use today, but when we send all the charts out to all the participants today, we will include an invitation to this webinar. This will only be for participants in today's webinar. This isn't a general Green Suite demonstration webinar. So at this stage, we're coming up very close to noon. I will see if there are any questions that you want to ask here. My contact information, email address is here, the phone number. This will be in the chart when you receive it. So are there any questions that you would like to ask? The economic analysis actually comes out when they do the proposed and final rules. Up until that point, when they're doing the risk evaluation, they are not to consider cost impact. But when they do the proposed rules, they have to do that analysis, and that'll be one of the details that we'll be looking for in their proposed regulations, because there's not a lot of detail about that side in the law itself.
Sorry, go back. I guess it's kind of a two-part question. Are they going to enlist the support of the OMB during that economic assessment?
I think that the way that it seems to work is that I know that OMB has already looked at the proposed rules that they're looking to put in the Federal Register. OMB's already looked at or is looking at those now. That's one of the delay factors, if you will, in them publishing them. So I think the answer would be yes. I think OMB is going to be involved at the end of each phase. So when they've finished the risk evaluation and published that won't involve OMB, but when they do the proposed rule, which includes the economic factors, I would anticipate OMB will be involved there. And when they do the final rule, which includes cost factors, I'm sure OMB will look at it again, because the cost impact in the final rule implementation is a considerable issue in the law. It's required to be in there, but only at the end stage.
Okay. Hey George, I got a couple quick questions.
Sure.
Number one, on page 5, you talked about low and high priority chemicals. I don't know if you can switch back to that.
I'm going to go back to the fifth chart. Yeah, we'll do that.
Okay. And basically under that, I'm going to use the phrase the guilty till proven innocent clause that basically says it's a high priority unless its data says it's a low priority. Based on your experience in the industry, is that going to create any issues going forward? I mean, is it going to be a log jam for getting toxicological data on some chemicals that haven't yet done it? I mean, what do you see as an issue with that clause?
Well, I think that we'll have a better feel for that when we see the proposed risk evaluation rule that's coming out imminently within a week or two. Because at this stage, we don't know what they're going to call sufficient data, for example. That isn't defined anywhere. And they're going to have to do that because, as you'll notice here under low priority, one of the criteria is if there's sufficient data, then they can call it low priority. Under high priority, the last bullet, if there's insufficient data, then they classify that as high priority, so they get the sufficient data. And so I think that the other element is that they're walking here before they're running. So they're starting with 10 chemicals. They're moving towards the point in 2 years where they're doing 20 a year. Most of those chemicals, or many of those chemicals, are going to be coming from different industries, and so or at least use categories, and probably different manufacturers. So the context here is that there are other, in that additional testing, additional information requirement, that provision may be spread across a larger funnel that's bringing information to EPA. It certainly will go across different industries and different trade associations.
Okay. Another quick question is, I think on page 4, you talked about the subgroup population, and I assume you mean there pregnant women and children and aged and that type of subgroup population.
Yes.
Do you see that provision causing any issues? I mean, you know, in my world, I do see occasionally focus on, babies and pregnant women and that kind of things. Is that going to be used a chance as a club to slow some chemical development down and chemical use down by chance?
Well, I don't need to it's a surprise to no one that particular reference was activist oriented. They wanted to make sure that these subgroups are considered. But when they published the proposed rule for one of the, or even the scope, when they publish the scope on one of these risk evaluations, they have to define then what subpopulations they're looking at. And that gives the public, including industry and trade groups, an opportunity to respond. So if they're not being fact-based, if you will, if they don't have documentation as to why a particular subgroup or specialty category is included, there is opportunity for that in public comment.
I guess my general thought is I don't think anybody disagrees. That's why it was so bipartisan that it needed to be refreshed.
Right.
The only thing I think we must all admit is there's a whole lot of activist groups that are engaged now that weren't 40 years ago.
Absolutely correct.
And okay. And then my last, along kind of that line, my third question and final question would be, does the precautionary principle go anywhere in there, or is it strictly hazard risk, etc., or is there this idea that we got to strive in chemicals and toxic chemicals towards precautionary principle?
I think the precautionary principle has been effectively controlled in the law, and I haven't seen the regulations yet, because it requires EPA to, in its scope, to identify the hazards that they're concerned about and what information they have. So again, when you're looking at hazard and you're looking at exposure information and susceptible groups, all of that has to be documented. So one of the goals that industry successfully achieved from their side was to make this process transparent. And so I think that in that context, the idea that the agency could fall back, you see, the precautionary principle applies more to hazard than risk assessment. And so the context here is where they were basing decisions on hazard only, then they could say, well, we don't have enough data, or there's some uncertainty here, so we're going to take the precautionary principle and we're going to say this may be a human carcinogen. That doesn't work now. They have to document if carcinogenicity is one of their concerns, they have to document why and what is the data that gives them that concern. So I think it sort of corrals the default to going to the precautionary principle.
Okay, thank you. That's good. Good answer.
Other questions?
Yeah, I have just a quick one related to the data on your green suite. Let's assume that a new chemical is developed. Okay, it will be related to some other ones, and we know there's various toxicology predictions and so on. So it's more about the robustness on the prediction on your scoring by looking more at green chemicals. How much? In an extreme that it may be something very novel, and there's a lot of information or background on it. How much input will you require from the customer in terms of actual testing? That would be one thing, or whether your green suite is based merely in, let's say, theoretical prediction. Which is it both will it be a combination of both to give your score?
Well, I want to separate. I understand your question, I think, clearly, and your question was about a new chemical. But I want to emphasize that in this law, for the first time now, EPA is required to look at existing chemicals, and that's and of the 84,000, that's the big elephant in the room, is all of these existing chemicals, some of which don't have much data either, but some of which have a lot of data. And so the context here is that the data that we have in our database on this normalized information is very effective for existing chemicals. We find that we have maybe 85 to 90% of a new customer's chemicals already in our database. Now, coming to your question on new materials. On new materials, that's the problem for everybody. And so one of the things that we're looking at as a company, as a third-party independent consultant, when we see these regulations, we're looking at how does what EPA says they're going to do help us in defining what we're going to do. So, for example, if you've made a new chemical and EPA says they need this minimal data set, then we're going to say we need that minimal data set, but industry would know that whenever they develop any new chemical. So they could develop that data set. But one of the provisions in this that's written into the law is that they do talk about the use of surrogates. So if you have a chemical that is similar to some other chemical where there is data, then EPA can justify bringing that data into the considerations, in the risk evaluation. So that's written into the law, and I'm anticipating that would also be seen in the regulations as it's proposed from EPA.
Okay.
I want to emphasize to everybody, I know lots of people have hung up, but I want to emphasize to everybody that this proposed rule that is about to be issued, I have a draft copy. In fact, I got it yesterday, so I haven't studied it completely. Mm-hmm. But it's very important for people to study that, because once EPA publishes that as a final rule, it's going to be very hard to change. So looking at that rule as to how they're going to do a risk evaluation is a very critical step and an open opportunity for anybody, whichever side of the issue you're on, to participate now.
Okay. Right. Thank you.
Mm-hmm.
Thank you.
Other questions? All right, I'll just remind everybody that we're going to be sending you the charts this afternoon and the invitation to the next webinar where we go in detail about Green Suite. That will also afford some opportunity to ask other questions as you've looked through the charts. So thank you for participating, and we look forward to talking to you again in a couple of weeks. Bye-bye.
Thank you, George.
Send a link to the new
Draft.
I'm sorry, send a link to what?
The new draft.
Yes. How do we get a copy of that draft?
I will look that up and see where I got that. So yes, I will include that in our transmission to you with the charts.
Great. Okay, thank you very much.
Yeah.
Thank you.
Hey,
Okay.
George, any follow-on questions that people get? Is there going to be an online forum so people can see those extra questions as we follow up?
The best place for that would be during that next webinar. I'm hoping that people will have looked at the charts here, which I went through very quickly, and in the context of that next presentation, that we could have an online forum there, which could be verbal. But I'm also more than happy to receive written questions and send it to all of the participants. That's a finite list that we have now, and that can be a way of expediting or facilitating the online forum. Any other ideas or suggestions?
Thank you.
Okay, thanks to everybody for participating today. We appreciate it.